Hello everyone, welcome to this video. In this video, we'll be solving this question which states that if x belongs to a group and x square is not equal to an identity element and we are given x raised to power 6 is equals to the identity element, then we have to prove that x raised to power 4 is not identity and x raised to power 5 is not identity, right? First of all, let's see these two cases. So we are given these two conditions with us. We have to first of all prove x raised to power 4 is not equal to identity. We will be using the criteria for contradiction. So first of all, we assume that if possible x raised to power 4 is identity, right? If x raised to power 4 is identity, then you can write x square. You can write 2 as 6 minus 4 and then you can use the laws of exponent to write it like this. Now you know x raised to power 6 is given to you as identity, right? And x raised to power 4, we have assumed this to be identity. So you see this becomes an identity. Therefore, from here we obtain x square is equal to our identity. However, this is a contradiction. Why? Because we have this condition which states that x square cannot be identity. Hence, whatever was our assumption, this was not correct. So that means we have x raised to power 4 not equal to e. And this is what we wanted to prove in the first part. In the second part, we wanted to prove this thing, x raised to power 5 is not equal to identity. We again use the method of contradiction. Here we assume that let, if possible, x raised to power 5 be e, right? Then we can write x raised to power 1. 1 could be written as 6 minus 5, right? And then you can use the laws of exponent to write it like this, separate the bases, right? Then x raised to power 6 is e. X raised to power 5, we have assumed this to be e, right? So this becomes e. So from here, x raised to power 1 becomes e. So that means your element itself becomes the identity, correct? So therefore, if your element is identity, in that case, if you take its square, x square, it would again be identity, right? So x square would be identity. However, we are given that x square is never identity, right? So we reach a contradiction here. So that means whatever was our assumption, this was incorrect, right? Hence we have x raised to power 5 not equal to identity element as proved, right? Next, they are asking to us that what can we say about the order of x? If you remember what is order of x, it is the smallest positive integer, right? It is the smallest positive integer such that when you take its power, it becomes identity, right? And for no other smaller integer than n, you would have it as identity, correct? So in this case, you are given x raised to power 6 is identity. So that means we have to look for the powers of x which are less than 6. So we have the options 1, 2, 3, 4, 5 and 6, right? Now from these options, you see x raised to power 4 is not equal to identity. X raised to power 5 is also not equal to identity corresponding to this and this. So therefore, this 4 and 5 gets cancelled. And moreover, x square is also not given to be equal to identity. So therefore, this option is also cancelled. So we are left with only these possibilities which are 1, 3 and 6. Hence, the possible orders for x, they could either be 1 or it could be 3 or it could be 6, right? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.